Come to the video of 2025 semi-final question MIT integration B. So let's solve this integral. So let's start off by rearranging this integral I. That's going to be the integral from 0 to 1 of the ln of x divided by the square root of I am going to factorize x out here. That will be 1 minus x dx. Nothing special here, just rewriting the denominator, and I'm going to do a substitution now. You can call it a trig sub if you like. So we can let x to be equal to sine square of theta, like this. So let's find what dx is really. So dx is going to be equal to 2 sine of theta cosine of theta d theta, right? What about the change in limits? When x is equals to 0, theta is going to be equal to what? Theta is going to be equal to the sine inverse of the square root of 0, right? So that is going to be the sine inverse of 0, that is 0. What about when x is equals to 1, the upper limit? Theta is going to be the sine inverse of the square root of 1. And that is equal to the sine inverse of 1, which is pi over 2. That's 90. So now let's take this our integral from the x world into the theta world. So I is going to be the integral from 0 to pi over 2 now of the ln of x. X is sine square x, sine square theta, divided by the square root of x, which is sine square theta multiplied by 1 minus x. 1 minus x, and x here is sine square theta, like this, times dx, and dx is 2 sine theta cosine theta d theta, like that. So I is going to be the integral from 0 to pi over 2 of, using the laws of logarithm, this sine square theta is going to be written as 2 ln of sine of theta divided by, we know that 1 minus sine square theta is cosine square theta. So the denominator is sine square theta times cosine square theta, because this one is cosine square theta, times 2 sine square theta sine theta cosine of theta d theta. 2 and 2 are constants, so they'll go in front. That becomes 4. The integral from 0 to pi over 2 of ln of sine of theta divided by the square root of sine square theta times cosine square theta is just sine of theta cosine of theta. The squares will cancel the square root, times sine theta cosine theta d theta. And what does this simplify to? 4. The integral from 0 to pi over 2 of the ln of sine of theta d theta. Why? Because this and this will cancel out pretty nicely. Then you have your integral I to be equal to 4 times the integral from 0 to pi over 2 of the ln of sine of theta d theta. Now, what is this one? This one, I have done this in my video. I have 2 videos explaining why this one is equal to a certain value. So the integral from 0 to pi over 2 of the ln of sine of theta d theta. This one is negative pi over 2 ln of 2. That is the value of this integral. So that is the log sine integral. So I have a video explaining this. I'll put that in the card and in the description. So if you want, you can check it out. So this is how, this is the value of this integral. So we can just plug that in. So I is going to be 4 times the integral from 0 to pi over 2 of the ln of sine of theta d theta. So that is going to be negative pi over 2 ln of 2, like this. And that is equals to 2 pi ln of 2. So this is the value of our integral. Therefore, if we integrate 0 to 1 of the ln of x divided by the square root of x minus x squared dx. This one evaluates nicely to negative 2 pi ln of 2. So this is the value of our beautiful MIT integration B question. So the key lies in knowing the log sign integral from 0 to pi over 2. Once you know it's equal to negative pi over 2 ln of 2, you can solve this integral quite nicely and effortlessly. So I thank you so much for watching this video. If you really find this helpful, make sure to leave me a thumbs up and subscribe to my channel for more content from Calculus Diaries. I thank you so much, and I will see you in the next one. Bye bye.